All right, 7-7, test prep questions, find the inverse of the function. Now, even though we have is the inverse a function here for your homework, remember that I've said that this part of this question is not going to be on your test. So you don't have to worry about that. We're still going to answer it though because I don't want to be that person. Um, but I just want you guys to know so that if you're feeling some nerves about that, hopefully it helps alleviate that. All right, um, let's take a look. I want to do number 9. All right, so to find the inverse of the function, we're going to switch the x and the y. So this becomes x equals y squared plus 4. Subtract 4 from both sides. X minus 4 is y squared. Now we want to take the square root of both sides. That square root cancels out the square. And we have y equals the square root of x minus 4. Now, is this inverse a function? Well, we need to check our graphing calculator, right? Whoops. So let's go ahead and pull that guy back up. All right, we're going to go to y equals, and the original equation, x squared plus 4, hit enter, and then square root of x minus 4. Close. Now that was the positive. Now we also want to include the negative, which I was neglecting to do because I thought it just automatically did that, and it doesn't. Shame, shame. All right. So this is the original, and this is your inverse. Is this a function? Absolutely not. And because it fails the vertical line test, this one is going to be no, not a function. All right, let's take a look at the bottom. These are some of my all-time favorite problems because we're doing the inverse of an operation. So that would be like doing the square root of a square, or multiplying and dividing, adding and subtracting. So what do you think these functions do? That's right. They cancel each other out. As long as the inverse of f, composition f. So they have to be the same function, but one is the inverse and one is the true function. So we're going to mark those out. The only thing that's left here is 10. We don't care about that. This is 0.2, this is negative 10, and this is D. Easy. All right, moving on to 7, 8. All right, with 7, 8, I would like to pick number 2 and number 7 to do from this first part. Graphing the function, this negative 2 is outside of the radical, so that tells me it's either an up or down movement. That would have been helpful if I had said it as I was drawing the right ones. And because that's negative, we know it's going down, right? So it is going down. Here's our sketch. And this is positive, so we know it is curving up instead of curving down. All right, so we're going to go to negative 2 on the y-axis, and there you go. Just that easy. And that's all you need to know for the test. Number 7, now we have this 6 on the inside. Well, this is the left or right movement, and we go opposite of what we want to think. So plus 6, we would think we're going to the right, but in actuality, that would be x minus h. So the only way we can get that to be a positive 6 and still meet the formula requirements, it would have to be negative 6. So this one actually moves to negative 6. And looking at the radical, it's not negative, so we know it's opening above. So 1, 2, 3, 4, 5, 6. There you go. All right, one final one. Let's do number 17. Okay, so we have y equals 3 times the square root of x plus 1 plus 4. Well, I can identify what the vertex is. Remember, it's going to be the opposite of this sign, so that would be negative 1 plus 4. So that's where my vertex is, and that's where I'm going to start right now. And 1, 2, 3, 4. Okay, so this is my vertex. Am I opening up or down? Well, this is positive, so that means I'm opening up. Okay. If we put negative 2 in, what happens to this? It becomes negative, so it doesn't exist. So we are not going to put in negative 2. We're not even going to put in the negative 1 because we've already done that. Let's go ahead and select numbers to the right of that vertex. So let's pick 0. I want to find numbers that will make that a perfect square. 3 and 8. And even that might be too many. Okay, so putting 0 in, we have 0 plus 1 is 1. Square root of 1 is 1. 3 times 1 is 3. 3 plus 4 is 7. Yeah, I'm not going to be able to draw this. I'm going to have to, we're going to have to go back to the drawing board on this one. It's putting 3 in. 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 plus 4 is 10. Put 8 in. 8 plus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. 9 plus 4 is 13. All right, so now that we have an idea of where our graph points are going to be, let's go ahead and 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12, 13. I don't know if I'm going to need that, to be perfectly honest with you. 1, 2, 3, 4, 5, 6, 7. Well, that's gotten off. 8. All right, so we know the vertex, again, is at negative 1, positive 4. We know the next point is at 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. 3, 10. So 1, 2, 3. And now we go up 10. So there's 7, 8, 9, 10. 8, 4, 5, 6, 7, 8. And then that one was way up here. So this is what that graph did. So this 3 ended up making that graph larger, making that curve bigger, not as narrow, not as level as the other ones are. Okay, that's it. Hopefully that's all been good for you. And if you have any questions, you know the drill.